the first time I saw a plating line, it's going to make me sound like a total geek, but I was like, this is so cool, right? You put something into a blue bath and then all of a sudden it comes out copper looking. Like, it's all chemistry. So it has to start there. And, we're the bottom of the food chain, but it's interesting. I enjoy it.
Hello, everyone, and welcome to the Altium On Track podcast. I'm your host, Zach Peterson, and I'm very happy to be talking today to Lenora Clark from ESI Automotive. We're going to learn a little bit about what she does in the automotive industry, and I think it's going to be a very revealing discussion for designers, especially the new designers trying to find their career path in the electronics industry. Lenora, thank you so much for joining us today.
Thank you so much for having me. I'm really excited to be here.
Absolutely. We're very excited to have you. We don't get to talk to many folks from the automotive industry. And one of the reasons I wanted to talk to you is because your background is quite diverse. And I think for some designers, it can be a bit difficult to find their path into the industry
Right.
and look beyond just, board design and layout. Maybe if you could give us the high level overview of your background and how you got to where you're at in automotive.
Yeah, it was an interesting path. I guess I am a chemist by education, and I work for a chemical company. When I first joined, it was called McDermott, and now we are McDermott Alpha Electronic Solutions. But I started out as a benchtop chemist, developing chemicals for PCB manufacture. And actually, my focus at the time was surface finishing. But with surface finishing being the last step in the PCB manufacture, I had a lot of interaction with end users, anyone from Ford to Intel to Apple. And so it was a unique way to look at the chemical needs through the needs and the desires and the challenges of the end user. So in our organization, we're normally formulating and creating processes for the PCB fabricator. But now it was a way to look at, well, what's the end purpose? What's that final need, and how can we change what we do from a chemical standpoint to enhance performance or reliability in the actual end use? So in the beginning, I was working with any end user you could think of. At the time, I was focused on immersion silver, which was a new surface finish for the industry. So it was exploding in all different areas, all different industries. And I worked my way up through the organization to, a project manager. And then I actually was the product line director for surface finishing. And that led me into being the director for OEMs. And for us in our circuitry division, that meant any OEM, again, telecommunications, the handheld market, military, aerospace, consumer products, and even automotive. And the more I studied automotive, the more I enjoyed it, especially in the time that we're in right now, where there's so much change and so much innovation. And about 3 or 4 years ago, I took the role in what we call ESI Automotive. So basically, ESI is a strategic initiative. It's not a business unit. It's basically our management team saying, look, we're ready to invest time, money, and resource to focus on the automotive supply chain, to look at the mega trends, electric vehicles, autonomous driving and advanced safety, what we call HMI or human machine interface. And with the understanding that this is a different industry, the mentality is different, the needs are different than other industries in electronics, and that it's a longer process to make the sell, in the automotive space. So that's kind of how I ended up here.
I think when a lot of people hear the words automotive and supply chain, uh, surface plating, the actual circuit board is probably the last thing they think about, especially these days, because for about a year, all we heard about on the nightly news was semiconductors and automotive chips and MCUs, and maybe you heard about power. And then maybe you heard about electric vehicles. And
Right.
so it's interesting that to hear someone that works so closely with the automotive industry and with car makers to talk about something beyond just the chips in terms of what goes on in the supply chain and what goes on with producing real products that are going to end up in vehicles.
Right. Well, somebody said it recently. Those chips don't float. Those chips are anchored to a printed circuit board, right? And as we explore these advances in automotive, the chip is getting more advanced, right? We understand that, but the circuit board is also getting more advanced. So they do go hand in hand. Yeah, there's, just like you said, this all we're hearing about is the IC substrate shortage. It's important, it's critical, but all these pieces need to come together in electronics for it to actually function, for the vehicle and these systems to function. So it's very important in their supply chain.
Well, you just quoted the slogan from our previous guest, Travis
Okay.
Kelly, from Isola Group, who was on I think a couple months ago. So I'm glad to hear someone else saying chips don't float because
Yeah.
it is true. Yeah, without that assembly capability, chips kind of don't matter.
Right. Exactly. Exactly.
And it's funny that you bring up the entire assembly because I mean when I tell people what I do, who are not technical people, they're like, oh, so like computer chips or something, and then you have to explain, no, those green plastic pieces that the chips actually sit on, like that's what I do.
Right.
Like, oh, really? That needs engineering?
And for me, the question is always like, well, what does chemistry have to do with that hard circuit board? Well, it all starts out as chemicals, right? I mean, the first time I saw a plating line, it's going to make me sound like a total geek, but I was like, this is so cool, right? You put something into a blue bath and then all of a sudden it comes out copper looking. Like it's all chemistry. So it has to start there. And, we're the bottom of the food chain, but it's interesting. I enjoy it.
So what does the a day in the life of someone in your shoes actually look like? I mean, what are you doing on a day-to-day basis when you're working with these large companies to ensure that what they're actually manufacturing is going to be functional? But I think also the other big piece of this in the automotive industry is reliability. It
Yes.
has to be reliable over what, a decade or more,
Yes. Yes.
typically, right?
Definitely. So what I do is I pull apart the hardware, you know, virtually, I guess, in my mind. I look at these different systems, whether it be a radar system, a camera, LiDAR, the domain controllers that are used to control all of these systems together. I pull them apart and look at the different pieces, not only what's on the printed circuit board, the joining materials for assembly, and even the IC substrate packages, and determine which of our materials can help these end users differentiate themselves. That would be from a enhanced reliability standpoint, miniaturization, design freedom, and then of course with that thermal management comes along. So it's one of the things we talk about all the time is the way or the trajectory of the automotive industry is adopting so many things we've seen in other market segments. High frequency and radar coming from military and aerospace, miniaturization, these different visual systems, different gaming chips that are used in vehicles today. That's coming from the telecommunications market, gaming, obviously. And so, what we've learned as an organization in the past from other market segments, we're bringing that to the automotive industry. The unique part, what you mentioned, is the enhanced reliability. So there's a couple things that comes with that. One is no automotive person wants to hear that this is how they do it in the handheld market, because if your phone breaks, it's not life threatening, right? It's not safety critical. But I have been educating the OEMs and the automotive tier ones on the fact that a lot of these handheld guys have been looking at enhanced reliability since day one. They look at things like microvia reliability from a different perspective than even the US military was. Like they were testing to extremes, they were testing things in situ to make sure that they weren't missing potential risks. So once you start to educate the car makers and the tier ones on what's been going on in the other industries, you know, there's more of a respect, I think, for what other people were doing. That being said, as well, we see so much development happening in the automotive space, right? We see them hiring from all different markets and gaining knowledge in all different areas, that this learning curve and the amount of innovation that's happening right now is so much faster, and so they're picking up quickly and they're adjusting, right? They're pivoting quickly to stay abreast, right? Because the biggest challenge in automotive today is that their bread and butter was the combustion engine, and we're headed toward a space where that won't exist anymore. So they need to pivot and reinvent themselves, essentially.
When we talk about more advanced automobiles, I think everyone thinks autonomous and cars are becoming computers on wheels. And so that workforce shift in the industry, I think for quite a while went more towards embedded and software and,
Yes.
you know, developers, building out all of the applications that were needed to actually run these more advanced vehicles, whether it's, at the firmware level or, now you've got cars that can connect to a web app in the cloud. And, that level of development. How has the need to develop more advanced electronics and then also make sure that they're reliable, has that been a tougher learning curve for folks in the automotive industry?
I think automotive was always set up with an understanding of, we're in a really hot environment and there's vibration and there's all different hot environment from the perspective of the vehicle itself, but then this changing environment outside, right? Are you in a cold climate? Are you in a warm climate? So I think that automotive has always designed with those things in mind. The challenge now becomes the extreme miniaturization. So moving to packages that are so much more challenging in these particular environments. I think that automotive has always focused on reliability. Now it's just a matter of, how do we work with substrate suppliers, PCB fabricators, everyone in the supply chain, to ensure that something that was made for a consumer product, how do we alter that to make it for an automotive specific application? And what does that entail? Is it changing some of the materials in the IC substrate? Is it making additional security measures like conformal coatings or different adhesives when you're bringing that onto the circuit board? So I think that's something that the designers are really considering, and I think that's something that your audience, should be well aware of. That this needs to be thought of as a system level, right? Everything coming together: the PCB, the assembly materials, the IC substrate, but also the housings. Right? All these housings are starting to change, and that's really important for the end use application, not only the environment, but also the high level of function that these electronics have.
That's interesting because there's a couple of threads here that I think are important to talk about. So, I mean, one, you mentioned the miniaturization,
Yeah.
right? And so with miniaturization, that I wouldn't have, I guess before I started doing anything with automotive, specifically in radar, I would not have, thought miniaturization as being a big driver of development, um, or HDI being, a big part of it. But I guess, when you really break it down, you got to put all those electronics somewhere, and you got, finite space in a vehicle. And of course the vehicles are getting sleeker and, more features and everything put into them. So with the miniaturization, I guess it makes sense that, maybe some components are moving to an HDI design.
Right, but Zach, I think we have to think of it from a different perspective. So many people outside of the electronics industry think of miniaturization as making something smaller.
Okay.
But we think of miniaturization as, yes, smaller, but so much more function. So now, if you think about these domain controllers, which is just basically a computer where information from a camera, radar sensors, they come together to make this informed decision in such a split second. There's tons of processing. So now you have the automotive industry who is using, I don't know, barely any BGAs. These domain controllers can have upwards of 14, 15, 16 VGAs, and the main processor has over 2,000 spheres, right? And so for those people maybe a little bit outside of design, the more connections of those IC substrates to the printed circuit board, the faster the exchange of information. So now the automotive industry has already jumped, you know, had to make this huge jump into miniaturization and a very heavy duty processing package. So you know how that filters down. Now we have to change the design of the printed circuit board. It has to be HDI. There has to be micro vias. And so that's in a sense where it's important, for design. And you think about miniaturization, but these central computers, they're massive. They're big and they get so hot there. Some of them are liquid cooled, tons of fans on them. So it's a lot going on. It's a lot to consider, especially in this time right now.
So I guess miniaturization is not just the board itself and the packaging, but also feature density, right?
Yes,
Yeah,
100%. You said it. You said it best. Yeah, feature density.
yeah. So you're packing more features into the application that puts more demands on processors. Processors have to be more advanced, even though they're in the same package, and
Yes,
so that's driving the use of, let's say, smaller or more workloads on, let's say, FPGAs and GPUs.
yes, yes. But to your same point about miniaturization, if you think about the steering wheel, right? We have so many things, so many functions on our steering wheel right now. Your radio, your phone. There's a big airbag in there. There's only so much PCB you can shove into the shaft of the steering wheel. So also that's another aspect of miniaturization, right? Can you get 3 circuit boards in there, or will you change your design to a molded plastic or, something more unique, flexible circuit, something to accommodate that smaller amount of space. So it plays both ways, right?
Sure, sure. The other, I think, thread that you brought up related to miniaturization is what's happening with enclosures. So you'd
Yes.
mentioned changes in the enclosure design. I think in the context of what you've been talking about with some of the demands that are on automotive electronics, the big focus in enclosure design would probably be for heat. Is that correct? Or
Yes.
is there more going on with the enclosure design?
From my understanding, heat, but another thing that we need to consider with all of the systems inside the vehicle, there's a strong concern on electromagnetic shielding, EMI shielding. Think about the radar sensor. It's sending out and receiving signals, but there's all other frequencies are coming into the vehicle at the same time. So that housing is supporting protection away from some signals, as well as protection from heat.
Well, then, in terms of the enclosure level design, I think when people hear shielding, they think, okay, metallized enclosure. That's probably part of it. But are they also using things like EMI gaskets, shielding compounds, or are those kind of like the last resort when EMC is becoming problematic?
I'm actually not that familiar with other things that they're using. My experience has been metals, but also plating of plastic. So if you think about a plastic shield, it's going to be lighter. They could partially plate it in some way so that they do have some shielding from that. So we've seen examples of that. You start to see examples of that also on the IC substrate itself. There's some companies that are doing EMI shielding directly on the molding compound. So there are changes, right? It could be a metal plate within, inside the plastic, could be metal itself as the housing, or it could be plating on plastic. So that's what I see mostly right now.
Well, you mentioned shielding on like the IC substrate. So I'm going to be
Yes.
honest. Integrated circuit design is an area that I don't work in, and I think it's important for me as a designer and for any other designers to know what the trend is so they know what to expect. But when you say shielding on the IC strips substrate, like what exactly does that look like? Does that mean that they're kind of like using the same type of board level shielding mechanisms you might use, but then bringing that or scaling that down into the substrate?
I'll look at it from a different perspective. So to fall in line with the path and the trend of miniaturization, for automotive to strive towards autonomous driving, you need sensors everywhere. A
Hmm.
radar sensor right now is a pretty significant size box. It's at least 3 inches by 3 inches, right? Or maybe even a little larger than that. You want to be able to put this anywhere. And so there's this direction towards creating a package instead of this entire system. Could you use something like MEMS as your sensor? And they'll do that for different applications, not just radar, but other applications in the vehicle. So now you've shrunk down this sensor into a package, into an IC substrate. And so you're designing it essentially the same, right? Where you have to have EMI shielding, you have to have an antenna on there to send and receive signal. So it's that trend of miniaturization as well as enabling as much possible function as you can have in the vehicle. Just imagine sensors kind of all over the place if you're going to have ultimately a machine that drives itself.
Yeah, I saw a graphic recently that was showing like all of the different sensors in an overhead view of
Yes,
the vehicle, and it wasn't so long ago when like everyone was oohing and awing over like your backup camera
I
with
know.
like the proximity sensor to another vehicle or an object or something, um, and then now 4 or 5 short years later, you see this overhead view of this graphic and it's like everywhere, 360 degrees around the vehicle, all kinds of sensors, long range radar, short range radar, ultrasonic.
Yeah, I mean, it's a great point. When I started this job 4 years ago, what I was supposed to do was pull it apart and say, what is the potential? So you looked at the vehicles that we were in, and like you said, there was one camera, just the rear backup camera, potentially two if somebody had forward facing. Now we know Tesla has 9 cameras, right? And if you looked at the projections, if you looked at, for example, Continental's projections of, okay, what the vehicle looks like today at level 1, level 2 autonomy, and then the number of sensors we need for level 5, it was exponential. It went from 2 cameras to 10 cameras. So, yeah, it's what it takes to be better than a human. This is a lot of sensors.
Yeah, I guess as humans we're a little spoiled because we have limited sensing, but we make sense of the world around us.
Yes.
Um, but I think within that, there's electronics in the background that make all of those sensors work together, and that's taking up even more space in the vehicle. And then they have their own reliability concerns. I think that would be separate from like the power system.
Yep.
And so, are you the one that has to then like tease apart and recommend to the OEMs or to whoever their outside designers might be, or if it's like a third party building this stuff, what they
So
have to do to, to
not
make
from
sure
a
that those systems are reliable?
not from a standpoint of things like redundancy. They're going to make their own call on redundancy. So many of these systems have literally 2 tracks. So 2 PCBs that function on and off so that they have higher reliability. You're not depending on one all the time. I speak to them from a standpoint of I can give you a different material that's going to extend the life of the solder joint. It's got more thermal resistant, it's got more vibration resistance, or I can recommend we have a joining material for the die attach that actually pulls more heat away from that die. The more heat you can pull away from the electronics, the longer characteristic shelf life you're going to get. So these are the recommendations that I make. I make recommendations based on a material perspective, both for reliability and for enhanced function. But the designers are really taking their own stand on how much, like I said, redundancy that they need or additional materials, not materials, but additional electronics within the vehicle. And I think you make a really good point about packing so much electronics into the vehicle now, and the electronics that will support the decision making, the sensing, and then making a decision. So this is another like kind of slight misnomer or misunderstanding, is that people talk about today, there's so many ECUs in the vehicle, engine control, not engine control, electronic control units. Used to be engine control, but now it's electronic control units. And people are saying, oh, well, the vehicle architecture can't support that much electronics. But what they're also finding is the vehicle harness is not advanced enough to support high speed data. So when information comes in, there's processing that happens there. Let's say at the camera, for example. Then that information gets transferred so that it can pass along the vehicle architecture, then to a central computer. So they're saying, we need more advanced electronics to understand what's happening at these sensors and then to transfer that information faster. And so because of that, the vehicle architecture and all that wiring harness inside the vehicle will change as well as we move towards higher levels of autonomy. So that's another thing for our designers to be considering as they step through this journey.
That's another area I think where the system designer has to step in and make a determination. You mentioned the data transmission between different parts of the vehicle. I think there's another area where maybe that's one of the few things designers think about. Um, I have some folks that I've worked with in automotive who are developing new products. They don't work at the OEMs, but that's one of the things that they definitely think about. And so I think there is some attention paid to that. But one of the proposals I had heard from one person was to move everything to fiber at some point, because with all of these vision systems and then radar systems all trying to get to higher and higher resolution and process more and more data, eventually you would there's a powerful incentive to go to fiber, because otherwise you have to do everything in parallel channels on copper, or you could do it all in fiber. What's your take on going into fiber?
I think the future of the vehicle architecture is not completely defined yet. I do think it will be less complex than what we see today, but I think there's still advances to make, different avenues, opportunities for how exactly this is going to look like, as we progress into increased levels of autonomy.
Sure. Do so. Do the OEMs drive a lot of these design decisions, or are they working with external firms? Like, how is this all structured in terms of who's deciding what the vehicle architecture looks like? What material decisions are being made? Because it seems to me like there's so many different cats to herd, as we like to say. There's so many different plates to juggle um, in making all these decisions and trying to get a subsystem built for a vehicle. Who's driving a lot of these decisions, and then at what point do they come to someone like yourself to get some sort of consultation on what's going to be the best path forward in terms of functionality, reliability, miniaturization slash feature density, all of these different areas?
Yeah. So it's an interesting shift in the automotive industry right now. For the electronic systems before, they used to just purchase them from automotive tier ones, companies like Bosch, Continental, Denso, Aptiv, and let them make a decision. And even multiple times they'd bring in multiple sources. So, for example, a car maker would say, okay, we need a braking system. It has to have these different types of functions and it has to fit into this space. And essentially, they bought a black box and then they would connect those things together. Now, the car makers are like, what is going on inside that black box? First, because they have to differentiate themselves if they're going to survive. And now there's so much risk connected to, if this machine, if this vehicle takes over some responsibility of the driving, I become responsible, right? Nobody's going to remember that the anti-lock braking system was made by somebody else. You're going to know what car it came out of, right? When there was a car issue, what car was that? So we see the car makers now essentially breaking open the box. They want to understand what's inside. They want to understand the function, the reliability. What do they need to be worried about? How is it tested? And then from the perspective of, you said the vehicle architecture and bringing all these electronics together, we start to see more joint ventures where car makers are working with one supplier. And this can be a traditional tier one, or it could look something more like today a Mobileeye. Mobileeye is owned by Intel, but this is a vision system company who comes in and brings the car maker like this entire system where there's different sensors and this central computing location to help make the decision. So I think we see a lot more of these collaborations. Companies like Mobileeye, companies like NVIDIA, they're working with tier ones, but they're working with car makers as well. And so there is that shift in a lot of decision and a lot of responsibility being placed on the tier one to now the car maker. And, with all of the influx of new entrants into the vehicle space, the car makers really have to be conscious of what they're putting into their systems, what they're putting into their vehicles, how they're differentiating themselves, and how they function, not only reliably, but performance. And so that's why more of these conversations happen with me now. Whereas before, the car maker probably wasn't too concerned about the chemical supplier or the company that was supplying these different materials within the space of electronics. And now they understand these things matter. I always say why the materials matter. There's a reason why we use certain plating processes or joining materials, because it's going to give you better performance. It's going to give you enhanced reliability, and that's the major aspect of my job, the major role of my job.
Well, then in terms of risk reduction for the automakers and for the, I guess, for the tier ones, um, whoever is going to be involved in that conversation, um, I'm sure they come to you before there's a problem. They're trying to be proactive and identify those risks early, not after there's something catastrophic or they invest time and money into,
Definitely.
these prototype systems and then something fails.
Definitely. We're involved in many more development projects than we had been historically. People bringing us in the early stages and saying, look, this is what we're thinking about. This is the direction we're going in. And sometimes, with any development, there's multiple paths, right? We're going to go down two different paths and see what wins. And that was always happening in any industry, right? Even outside of automotive. But now we're brought to the conversation, we're brought to the table much earlier than we had been in the past. Because, like you said, nobody can afford to fix the issue after the fact. They've got to be able to anticipate what's coming before it even goes into the vehicle.
Yeah, fixing the issue after the fact. I mean, after the fact could not just be, of course, somebody gets injured or worse, and then of course recalls and things like that. But I mean, the damage to the brand has got to be
Exactly.
massive.
It's not just financial, it's reputational now. Yeah.
Okay, yeah. So I guess there is a lot of incentive, whether you're an OEM or supplier, to come to someone like ESI Automotive and get these questions answered early.
I
Um,
think, I think it's important to have these collaborations and to work together because bring in your chemical supplier, bring in the PCB fab, the EMS, the assembler, whoever it is, because if we're going to do this quickly, right, if you're going to innovate fast enough, it's got to be done with all different types of experts. And, that's another change in the automotive industry. There was development that took 5 years. Now we see development happening in 6 months. So it has to be a different path. It has to be a different tactic than it was historically.
a reduction from 5 years to 6 months, that is a big delta.
Yeah.
That's a big delta. How do companies manage that? The system is more advanced, and on top of that, you've compressed the time to get something out there that's working and possibly into scaled production. So how are companies managing that? I mean,
I
are these I guess I should ask, are these types of front end conversations with someone like yourself really important for identifying all of those potential risks ahead of time, so that way they can cut out redesigns, whether it's at a system level, board level, whatever it may be?
Yeah, I think the level of collaboration is what's enhancing this. So car makers now directly going to IC substrate suppliers and companies that, OSATs, for example, they can go in and have these conversations with the, with the OSATs, then there's an understanding between the two organizations on this is what we need, this is the risk involved from the OEM level, and the OSAT being honest and saying, this is where we are today. Okay, now we need to fabricate, design, manufacture to a different level of reliability. So closing the gaps on the communication and being more collaborative is helping this. Also, the fact that you're taking technology from other industries, it's not all brand new. It's not like the automotive industry invented the camera, right? The camera exists and in all different spaces, even radar, right? We're taking that from military and aerospace. So make sure as an industry as a whole, there's a lot of communication and a lot of information exchange because ultimately everyone wins in the end, right? Everyone wins. Even as the consumer, we win if there's better product out there. So
Sure, sure. So, I'll be honest. Sometimes, if you're not part of these discussions like we're having now, sometimes an industry like automotive can appear quite opaque and difficult to, get into, at least in terms of these conversations what we're having. But if someone has a great idea for a product or they want to develop something, um, I'm wondering, uh, how is it that they can get in on this type of conversation, or have or get access to the information that we've been alluding to throughout this discussion that we're having now? What's a startup to do? Do they need to go to an EMS service that works directly with, let's say, an OEM like Ford or GM, or do they come directly to you? How does that process play out?
it's such a great question. And I still think it's a long road. I still do think it's a long road for a startup or for a brand new invention to be incorporated into a vehicle. Um, it's a high risk for them. So you would really have to differentiate yourself significantly. Um, I unfortunately I don't have a straight answer, but I still think even though we see significant changes in the automotive industry, we still see them as very cautious because they have to be, right? They have to be.
Well, that's fair, and I get risk aversion, and if I guess it almost sounds like in some cases the industry takes the approach of, if it ain't broke, don't fix it. Um, However, if someone does invent a better mousetrap, what do they have to do, I guess, to impress an EMS
Or
who could
maybe
then,
maybe
pitch that
make their own
idea?
company like the EV companies we see today, right? I mean,
The capital allocation environment we're in right now, I don't think is very friendly to that. So, what's I agree with you. That's a great path forward, and if you can convince investors to help you build the brand up and get your foot in the door for some of those discussions, more power to you. But if that's not for you, or
yeah,
that's not accessible in the current market environment, what is the path
I
forward?
think you also have to think about, they use this term mobility now, right? Mobility is so many things other than the vehicle that you own and drive, right? That the everyday person has in their driveway that they own and drive. Mobility changes now to delivery systems, ride shares, all different types of transportation, whether it be a human transfer or a package transfer. So I think there's a lot of different avenues now to get the technology to be looked at and then, prove yourself there. And then maybe it gets into the sight line of a big car maker. But I think there's a lot of different avenues now, aside from just the traditional vehicle, traditional car.
Well, it sounds like some of the great innovators out there need to just go on some kind of guerrilla marketing campaign to get their awesome
Sorry, I don't have
hardware
an
in
easy
front of the
fix
right
for you.
people.
Yeah.
Right. Well, I think we're getting up there on time, but this has actually been a really revealing discussion. And like I said, I think sometimes automotive can be a little opaque if you don't work in it very deeply. I've dipped my toe in a little bit in radar, but beyond that, all the stuff that you've brought up is totally new to me. So for me, and I hope for many other folks that are listening, this has been a very revealing discussion.
I hope so. I enjoyed it.
Well, thank you so much to everyone that's listening out there. We've been talking with Lenora Clark from ESI Automotive. We have some great links in the show notes, so please check out those resources to learn more. And you can also sign up for the Electronic Design to Delivery Index to help you navigate volatile supply chains in the current times. Thanks again to Lenora Clark. Everyone out there listening, make sure you subscribe, hit the like button, and last but not least, don't stop learning, stay on track, and we'll see you next time.